Today, we're going to answer this question, which relates to writing an amortization table or amortization plan for a geometric progression amortization. So, in a geometric progression amortization, each payment either increases or decreases, not by a constant amount like in an arithmetic progression, but as a constant percentage or proportion each period. And also to calculate the payment, or at least to calculate the first payment, we can use the present value formula for geometric gradients in general. So I'll review what that is in just a minute here. First, let's read what the question says. Prepare an amortization plan of a $15,000 loan to a 5-year term with annual payments at an interest rate of 10% per annum, with a capital payment and interest that'll increase by 20% every year. Okay, cool. So in order to do this, what we're going to first do is we need to figure out what is the first payment, which they didn't tell us. However, that's completely fine because we can actually calculate the first payment using the present value formula of geometric gradients. So let's do that. The present value is equal to A, the first payment, times 1 plus g to the power of n times 1 plus I to the power of negative n minus 1 all over 1 plus g minus 1 plus I, like that. And in this case, present value is the amount of the overall loan in this case, so that's going to be $15,000. Then n is the number of years. It's a 5-year term, or I guess like number of periods, but in this case, a period is going to be a year. And then we also have the interest rate per period, which in this case, since it's yearly, it would just be 0.1, right, 10%. And then g, the gradient, is going to be 0.2 for 20%. The payments will increase by 20% every year. So let's plug all these values in and solve for a. So that means that $15,000 is equal to a times 1.2 to the power of 5 times 1.1 to the power of negative 5 minus 1 all over 1 plus g, so 1.2 minus 1.1, which I suppose we could just write as 0.1, but either way, I think that's good as well. Okay, so first thing I'm going to do is I'm going to find the coefficient for a, which is all of this. So let's talk about how to do that. So I'm going to start with 1.1 to the power of negative 5, hit equals, and then times 1.2 to the power of 5, hit equals again, and then minus 1, hit equals. Then we're going to divide by 0.1, right? For the bottom here, 1.2 minus 1.1 is 0.1, hit equals again, and I get 5.45 approximately. So 5.45a is equal to 15,000. So then if I just divide 15,000 by 5.45, I get that a is equal to 2,752 and 29 cents. So therefore, that's the value that our first payment would have to be. And that might seem low, but keep in mind that future payments are going to be going up by 20%, which is quite a bit. And so it doesn't surprise me that the overall first payment is actually not that large, not as large as we would potentially expect. Okay, so now I'm going to start to write the amortization plan or amortization table. So let's write down our categories here. So first we're going to have our number of years, then our loan balance, then our capital, also can be principal in some cases too, interest, and then our total payment, also known as capital plus interest, but this is the total payment made each time with both. Then I'm just going to draw some lines, line, 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 like that, and line at the bottom. Okay, and then for years, it was a 5-year term, so therefore for years 1, 2, 3, 4, 5, our starting loan balance, according to the question, was $15,000. And then our first payment was $2,752.29, and that's going to go into capital plus interest because that payment is including both capital and interest together. Okay, So now what we need to do is we need to figure out, okay, well, how much of this is capital and how much this is interest. And for that, we need to remember that the interest rate is 10% per year, right? 10% annual, right? And so I'm going to take this loan balance, $15,000, and I'm going to multiply by 0.1 to get 10% of that amount. And 10% of that is going to be $1,500. So that means $1,500 of that was interest, and whatever else we paid that month or that year in the first payment is going to be part of capital or principal. So $2,752.29 minus the amount that we gave away for interest, the $1,500. That means we paid down $1,252.29 of capital that year. So now I'm just going to subtract that from the overall loan balance because that's money that now we no longer owe. And so therefore the new loan balance at year 2 is $13,747.71. Okay, now I'm going to multiply that by 10% to find out how much interest we have to pay on that, because now it's a year later, we owe another year's worth of interest, which is 10% on our balance. So that means that we owe $1,374.77. Oh, and actually something I should have done before is note that every year the payment amount goes up by 20%. So that means that we can take the first payment, $2,752.29, and we're going to multiply it by 1.2 to get something 20% higher. So times 1.2, that means in year 2 it's $3,302.75. And then if we multiply by 1.2 again to get it to go 20% up a second time, now it's for the third year, the payment is $3,963.30. And then multiply by 1.2 again, we get that the next payment for payment year 4 is $4,755.96. And then we multiply by 1.2 one last time to get the final payment, which is $5,707.15. And at that point, the loan will be fully paid off, which is good. Okay, so now let's continue. So where were we? We were just figuring out the capital for year 2. So to find that out, we can do capital plus interest, which is $3,002.75, and subtract $1,374.77 to get that. Therefore, the part of the payment that must have been the capital is $1,927.98. And then we can subtract that from our total loan balance. So we can subtract that from $13,747.71 and get $11,819.73. Okay, and now we're going to figure out the interest we have to pay on that. So multiply by 0.1 or 10%. And that tells us the interest we have to pay on that is $1,181.97. So then we're going to subtract that from our capital plus interest to find our capital. So subtract that from $3,963.30. And we get that the capital we paid off is $2,781.33. All right, and then we can subtract that from the balance. So subtract that from $11,819.73, which means now we only owe $9,038.40, which seems like a lot. It seems like, oh, we're almost done this whole loan thing, and yet we haven't even paid off half the overall balance. And that's because these capital plus interest payments keep going up and up and up. And so we make basically a lot of the progress towards the very end, as you're seeing here. So year 4, we owe $9,038.40. And the payment we make is $4,755.96. Let's find out how much interest we have to pay on that loan balance by multiplying it by 0.1. That means that the interest we must pay is $903.84. So then subtract that from our overall payment to figure out how much principal we paid off. That means that $3,852.12 got paid off. And then we again subtract that from the overall balance, $9,038.40. So that means our loan balance now is $5,186.28. And then let's find out how much interest we have to pay by multiplying by 0.1. That means we have to pay $518.63 of interest. And then we can subtract that from the principal plus interest payment, which is $5,707.15. And that gives me $5,188.52. Actually, you know what? That is further off than I was expecting. I think due to rounding error, we got slightly different amounts, right? Because we would expect for the loan balance and that last capital payment to be the same. However, it is close enough that this does work. There was probably just some rounding error in there somewhere. Okay, so now if we add up all the capital, we're going to get somewhere around $15,000 because that's our overall loan balance. If we get a couple dollars extra, a couple dollars less here and there, probably just some rounding error there, and that's fine. So $1,252.29 plus $1,927.98 plus $2,781.23, or sorry, 33 cents, I think. 33 cents, yep. Plus $3,852.12 plus $5,188.52. Okay, yeah, so that's a little bit over. That's $15,002.24. And then the interest paid was $1,500 plus $1,374.77 plus $1,181.97 plus $903.84 plus $518.63. That is $5,479.21. And if we add that to the principal, that means that overall we had to pay $20,481.45 in terms of overall payments over time. And so there we go. That is going to be our amortization table for this one, and we'll see you for the next one. As always, if there's any questions, please leave those down in the comment section.